Hi, welcome to my YouTube channel Easy Aviation. Here we discuss about the short and simple topics about the aviation. Definitely the interesting one. Today's topic of discussion is aerofoil. So here in this discussion we'll learn about the aerofoil definition, how the force are acting, lift and the drag force, center of pressure, types of aerofoils, terminology which are required to define an aerofoil, and various curves which is required to define an aerofoil. So first we'll start with the definition of an aerofoil. So aerofoil is any part of the aircraft which converts the air resistance into a force useful for the flight, that is a lift force, is called as an aerofoil. So I'll just define. There's a combined theory, like let's say there is a plate and a force is acting or on this side, so it will resist, it'll give 100% resistance to that. But if you incline the plate at an angle, let's say 45 degree, and then you put a force, so that force will try to act on this plate at an angle, and which does gives a little bit amount of force resultant in this direction. For example, the kite. So what generally we do in the kite, we pull it with a string, and the air force will try to keep this kite upward. This theory you can actually use it when you're traveling through a car or through any bus. You take out your hand outside the window and try to make just open your palm, and initially you try to put the palm just in 90-degree position. You will feel a lot of drag because of the air resistance. Just tilt your palm in 45-degree orientation, and then you feel that your hand is going automatically upward. So this is one theory. This is also called as momentum theory, and this is basically on Newton's third law. For every action there is equal and opposition. So this is action, and since it is putting a force in the upward direction, there is a reaction on because of which that plate is going upward. Okay, another theory is because of the is about the Bernoullis Principle. So in which actually does not apply on this kind of plate or section. Let's make a section like this in which air is flowing, and the air which is flowing on the upward direction has a smooth curved path to flow, and as compared to the downward, because it has a hindrance, it will go there. So the velocity upward is more as compared to the velocity more and less. And what principle Bernoulli says, that where the velocity is high, there is a pressure, there is a low pressure which reduces the pressure here, which creates a force upward, which is known as lift force. I'll take a new page. So I was discussing about the Bernoullis Principle. In this kind of section, an aerofoil section, whenever a fluid is or air is flowing, because of the smooth path, the velocity up is at the upper section is more as compared to the lower section. Because of this, the pressure is lower, and which creates a force at the upward direction. And definitely this body is moving through the air. It creates a drag because of the friction between the air and the surface, which also has a force in this direction, which is called as drag force, and the force which is in the perpendicular to the airflow is called as lift force. So resultant force will be in somewhere there, which is a resultant force. So this is the definition, or how the lift and the drag is generated. So now we'll discuss about the center of pressure, like from where we consider the point this pressure, this lift and drag is generated. So there are many experiments which are undertaken, where they have taken this kind of section and they have fitted with the manometer tube in all the section, and then they measure, and when this section was kept in a airflow, they found that pressure at different level at different points are at different level. So when they draw the pressure distribution, they found, I'll just explain you. this kind of structure. That means here it is a negative pressure, and in the front forward section negative pressure was more as compared to the lower part. So that means that here the pressure is low and does create a lift force. So when you conclude, you find that that summation of all the pressure will give you one point, which is all called a center of pressure, from where all the lift force and the drag force are considered to be acted. Next we'll go to on the type of airfoil. So I'll be explaining you two very basic, that is, one is symmetrical aerofoil and another is asymmetrical aerofoil. So in the symmetrical and asymmetrical, before explaining to that, I'll just explain the terminologies which are there to explain an aerofoil. So here is a picture which I have taken. So this is a kind of a aerofoil section. So first is the chord line. So if you join, this is called as leading edge, this point is called as trailing edge, this is upper surface, this is lower surface. When you join a straight line from leading edge to trailing edge, the length between them is known as chord. Okay, I'll erase this part. I'll again try to explain it. So this is a aerofoil section. You make a straight line between leading edge and trailing edge. This is leading edge, this is trailing edge, and this is known as chord line. Length between them is called as chord length. Okay, you make an imaginary line which divides the complete aerofoil in two parts, upper part and lower part. This is upper part, this is lower part. So this is known as camber line. So here it is given as, this is center straight line is the chord, and the line which is dividing the complete section into two part is known as camber line, and the maximum distance between the camber and the chord, I'll again draw it with a more camber, which will make picture clear. So I'll take a aerofoil like this. So the straight line between trailing and leading edge is the chord. If I divide the complete aerofoil into two part, this will be the camber. I'll write it here, the camber. Okay, and another terminology is the thickness. So at any point where the thickness where the aerofoil has the maximum thickness is known as, is what the aerofoil thickness has. This is the maximum part. So these are the major part: trailing edge, maximum thickness, where the foil has a maximum thickness of it, like as it is shown here. Then there is a chord. Maximum camber position is the point where the difference between the camber line and the chord line is there. That is known as camber of the aerofoil. And yes, so this is how an aerofoil is defined. So since I was explaining about types of symmetric and asymmetric, so any aerofoil section in which the chord line and camber line coincide, which has zero camber, is known as symmetric, and anything which has a camber is positive or negative is a asymmetric. So it can be positively cambered aerofoil or a negatively cambered aerofoil. So now coming to the end of the video, I'll tell you how this aerofoil, what is the relation between these aerofoil lift generation with respect to the angle of attack. So yeah, first of all I'll define the angle of attack. So angle of attack, like if this is an aerofoil and this is a chord, this is the center of pressure. The angle between the, let's say this is a airflow, so the angle between the airflow and the chord is known as angle of attack, alpha. So as I was discussing about the different experiments, so experiment was carried out by increasing or decreasing the angle of attack. That means first orientation they have taken like this, second orientation with a more angle of attack, and they put the airflow in this from this direction, and then they checked how the pressure was varying. So I'll tell you how the result varied by changing the angle of attack. So first I'll tell you about the lift versus angle of attack. So I'll take angle of attack here and lift or coefficient of lift. I'll tell you what lift and coefficient of lift in some another video. So we'll measure the coefficient of the lift as the parameter for the lift. So as you increase the angle of attack, lift also increases, but at some point, like let's say we increase the angle, this is the chord, this is the airflow. If we increase the angle of attack to at some extent, the flow which is going from the upper surface breaks down and separation happens, because of which the lift reduces at a drastic rate. So every aerofoil has a critical angle of attack, after which the lift reduces a lot. So this is how the lift versus angle of attack curve goes for a symmetric, as I have told you, symmetric aerofoil. That means at zero angle of attack, the flow at upper surface and lower surface are equal, and thus not creating any lift. But if you speak about the cambered or asymmetric aerofoil, even if it is at a 0 degree of 0 degree of angle of attack, then also it creates a lift. So for a asymmetric, curve goes like this, and as you can see, at minus at 0 angle of attack also there is some lift, coefficient of lift. So this is the first relation between any aerofoil, angle of attack and the lift generation. If we speak about the drag, that is coefficient of drag and angle of attack, we'll call it as alpha. So again I'll take angle of attack on x-axis and coefficient of drag. So yes, so any aerofoil has, as I told you, is producing lift also and drag also, and efficient aerofoil is those which produce more lift than drag. So yes, so initially the drag is less, and as I told you, as it crosses the critical angle of attack, which I discussed in the previous graph, if angle of attack is critical, this is critical angle of attack, it will create a tremendous amount of drag. So here these are the coefficient of drag. So now the last curve, which is very important, is the lift to drag ratio versus angle of attack. So lift to drag ratio we calculate because this what shows the efficiency of a aerofoil. So any aerofoil should produce more lift than drag. If anything producing more drag than lift, then it is a air brake and not a aerofoil. So the curve goes like this, again angle of attack on x-axis and lift to drag ratio in the y-axis. So initially it goes, the lift to drag ratio is increasing, and a particular angle it will reduces. So this is the critical angle of attack, or stalling angle, also called as stalling angle, and there is a particular angle at which the lift to drag ratio is maximum, that is producing maximum lift with minimum drag. So these are the curves. Okay, another curve I'll explain, that is the moment of center of pressure. As I've told you, whenever the aerofoil was tested with manometer tube at different angle of attack. So another curve I'll just explain. I'll take angle of attack on x-axis, and this is the length of the I'll just draw this is the length of the aerofoil. So if I take a ratio, it is 100% or 1 to 0. could be 0.8, 0.6 and 0.2. So center of pressure, as the angle of attack is increasing, the center of pressure moves ahead, and after a particular angle of attack it goes back, because as what the experiment has depicted. So these are the important curves which defines how the aerofoil, or how um, the aerofoil behave at different parameters, at with drag, how the drag, lift, lift by drag ratio, how they changes, how they behave with change in angle of attack. So I had explained all these parameters, which is very much important if you are discussing about the aerofoil. So here I sign out. Thanks to watch my video. Thank you so much. Any doubt, any specific parameters you want to know about the aerofoil, please let me know. Thank you.